This is AP Calculus AB. This is Mr. Snell going through some problems. Let's start with number 11. This was the first question people had questions on. Yep, we have a differential equation, which means we're probably going to have a slope field. We do, and probably going to do some finding particular solutions, I'm guessing. It's been a while since I've seen this problem. So part A, go ahead and sketch the slope field for all of those 12 points. Okay, so I'm going to do where x is equal to 0 first. So that's going to be all of these points. Those are all x is equal to 0. The way that I do that is when x is 0, everything here is going to be 0, which means the slope here is 0 all 4 times. So I'm just going to do a slope of 0, and I guess I should draw them correctly. 0, 0, 0, 0. And then when x is 1, if I come out to these 4 points out here, when x is 1, that means this leading number is going to be just 1, which means I'm really only dealing with this y minus 1. When I do y minus 1, this y, the height here is 0, so 0 minus 1 is negative 1, so I have a slope here of negative 1. And then this has a height, a y value of 1. 1 minus 1 is 0, so it has a slope of 0. And then right here we have y is equal to 2. 2 minus 1 is 1, so it has a slope of 1. Oops, let's leave that there, slope of 1. And then this is going to be 3 minus 1, which is 2, so this is going to have a steeper slope of 2. And then the other side is going to be the exact same thing as we just did these last 4 lines, because all I'm doing is changing x from a 1 to a negative 1, and since it's being squared, it's the same thing. So let's go ahead here and say this is going to be a slope of 2, a slope of 1, a slope of 0, and a slope of negative 1. Alright, so that was part A. Let's do part B. Describe all points in the xy plane for which the slopes are positive. Okay, so essentially it's just saying, hey, take your our dy dx up here and say that this is positive, specifically this x squared times y minus 1. So let's come down here and say the quantity of x squared minus 1, or x squared times y minus 1, and that needs to be greater than 0 in order for it to be positive, right? So how do I do that? Well, let's go ahead and break this up, because this x squared, that will always be positive, or I guess I should say it's always going to be non-negative. It could potentially be 0 if I plug in 0, but if I plug in negative 1, it's going to be 1. If I plug in negative 2, it's going to be 4. If I plug in 3, it's going to be 9. This is always going to be a non-negative number, which means I'll go ahead and label that here too in our notes. So this is going to be non-negative, which means I don't have to worry about it aside from when x is 0. That's the only problem, and then that will make this whole thing equal to 0, which is not positive. That's 0, right? So the next thing that I have to deal with is I kind of am ignoring this x squared, and I'm only dealing with this y minus 1 is greater than 0, and that's a pretty straightforward equation to solve. Let's do that in a different color. So essentially now I have y minus 1 is greater than or equal to 0. Add 1 both sides, y needs to be greater than 1. So the full answer, I know that the answer key is a little bit off. Our full answer for this one is slope is positive, and again, slope I'm defining it as dy dx, that is slope, right? So I'll say slope is positive when this y is greater than 1, and when x is not equal to 0, and x is not equal to 0. And that's all you have to say. Part C, okay, so this is where like the bulk of the points come from, because you're finding the particular solution. Whenever you see the particular solution, that means we're going to do our 4 steps: separate, integrate, evaluate, and isolate. So let's start it off. What is our dy dx again? I'll just rewrite it. So dy dx, that is x squared times the quantity of y minus 1. All right, let's do step number 1, which is to separate. You don't have to write out these steps. I'm doing it for our notes so that you know what I'm doing. So if I separate, I'm going to divide both sides by y minus 1 here. So I'll have 1 over y minus 1 on the left hand side, and I still have this x squared on the right hand side. I'm also going to multiply both sides by dx, so this dx is going to come over to this right hand side. So I have x squared dx, and the dy is still over here on the left hand side. That's it for separate. Nothing special there. Let's go on to the next step, which is step number 2, to integrate. integrate. So when we integrate these both, I'm just rewriting them with integral symbols. So integral, I guess I can go ahead and change this. I don't want to leave it as a fraction because we don't like taking integrals or derivatives of that matter of fractions. So I'm going to make this y to minus 1, all that to the negative 1 power dy. And on the right hand side, I'm going to just leave that as, oh, I should write the integral as well. The integral of x squared dx. Okay, I still haven't gotten any points yet. Time to actually take the integral now. So if I take the integral of this one, I have to always take dinner. Whenever you do an integral, just do it. Like, unless you're really good at knowing when to use and when not to use dinner, just always find dinner. So I'm going to do some scratch work out here. So my dinner here, well, the derivative of y minus 1 is 1. Okay, so I didn't have to do it. Okay, what about this one? This doesn't even have an inner, so I don't have to worry about it. Cool. Just always check your dinner every single time that you have an integral, 100% of the time. So now that I take the antiderivative, how do I take the antiderivative of negative 1? And I'm going to do it wrong, just to show you why it doesn't work. Well, okay, I think you're going to add 1, so it's going to be y to minus 1, all this to the power of 0, and then you divide down, divide by 0. Oh, okay, that's not what we wanted. You can't divide by 0. Whenever you have this type of rule, anytime you have a power to the negative 1, this is the natural log. So I have natural log of that inner. And I have to do absolute value too. So absolute value of y minus 1 and absolute value is equal to. And before I do the right hand side, why did I do absolute value? Well, because natural log can't accept negative values. So we're making sure that the domain is correct here by having these absolute values. And then finally, taking the antiderivative of x squared, well, goes x to the power of 3, goes up a power, and then divide down. And I need to have plus c somewhere, so I might as well just put it right there. Typically, we put it with the x's on the right hand side. Okay. That's, you just got a point. You'll probably get like 1 point for taking the derivatives there, 1 point for finding c, type of thing. Let's do the next step, step number 3. So let's switch another color here. Step number 3 is going to be kind of long. How much room do I have left? Okay, I'm going to move over to the right here because I know that's going to be a long step. Step number 3, and it kind of leads naturally into step 4, which is evaluate. Evaluate. So evaluate means just plug in, right? So I have my x is 0, my y is 3. So in our equation down here in black, I'm going to plug in those values. So it's going to now say natural log of y is 3. So 3 minus 1 is equal to, and then I'm plugging in 0 to the power of 3, all divided by 3 plus c. And just by doing that one step, you've now gotten the majority of the points. You don't have to do anything else on the AP test, right? For us, I want to show you the full steps. You can go ahead and skip the video if you don't think that you'll need to do this step. But you should always know how to simplify in my class. So this is natural log of 2. Notice I dropped the absolute value symbol because I know that this is going to be a positive already, and that's equal to c. Okay, and then step number 4 is to isolate and then plug in our c that we just found. So let's start over with blue again. So step number 4 is to isolate. And again, I'll put a little asterisk here, and this is optional. I maybe can write a little bit bigger. Optional. I'm using a new setup here, which is why it looks slightly different from my handwriting. I'm using a Windows computer instead of my MacBook Air. So step number 4, isolate. We want to isolate for y from this black. So how do we do that? Well, right away I can plug in c, so let's go ahead and write that down. So natural log of absolute value of y minus 1 and absolute value is equal to x to the power of 3 divided by 3 plus this natural log of 2. So how do I get rid of the natural logs? It's called exponentiation. It's a fancy way of saying do e to the power of that side and e to the power of that side. You have exponentiated both sides. So there it is. There's my new equation. The equal sign should really be down here now, but whatever. When we do that, the e and the natural log can cancel out here, and our new line down here is going to say, well, e to the natural log is crossed off, right? So I just have absolute value of y minus 1, and absolute value is equal to, okay, this is still e to the power of x to the power of 3 divided by 3 plus, I guess, I was thinking of doing times to skip a step. Let's just go ahead and leave it as plus natural log of 2 in the exponent here. So the next step that you can do here is to separate this into two pieces. So on this right-hand side, left-hand side, I'm not going to change it. I could, but I don't want to do too many steps at once for this video. This is now e to the power of x to the power of 3 divided by 3 times e to the power of natural log of 2. And the left-hand side is still y minus 1 with absolute values. You'll probably see that the e and natural log over in this side cancel each other out for our next step. So I'll go ahead and just draw that now. That's gone. So my right-hand side is now just 2. I'm going to bring this 2 in front. Usually the exponents are in front. So this is going to be equal to 2 times e to the power of x cubed over 3. And on the left-hand side, let's get rid of that absolute value symbol. So how do I do that? First, I think I need more room. So I'm going to bring all of this stuff over that way. What color am I on? I'm on this color. Okay, so to get rid of the absolute value, I'm going to drop it. So I'm going to say y minus 1, and then I'm going to get rid of it by doing plus or minus on the right-hand side. That's how you undo an absolute value symbol. And finally, we can add 1 to both sides. So adding 1 and y is equal to 1 plus or minus 2e to the power of x cubed over 3. And we do have to choose if this is a plus or a minus. So what you have to do for your final step is plug in your initial values. X is 0, y is 3. It has to be one or the other here. I think my answer key didn't choose, so I don't know what's going on there. I'm seeing my answer key at the same time. Dual screens, it's so nice. So if x is equal to 0, I said, y should be 3. Let's check it out. So if x is 0, that means that this is 0 cubed, which is 0. 0 divided by 3 is 0. This is e to the power of 0. Anything to the power of 0 is 1. So this whole thing is 1 when I plug in x is equal to 0. And then 1 times 2, this whole thing now is 2. So it should be plus or minus. In order for this y to be 3, it has to be a plus. It can't be a minus, otherwise you get negative 1 for your y value. So by plugging in, we can kind of get rid of the negative symbol, and you can have our final answer. Let's just carry on the next color. My final answer is y is equal to 1 plus 2e to the power of x cubed all over 3, and final answer, box it. Notice that you don't get a final answer and box it until you do step 4, but by doing all this work, I'm pretty sure you'll only get 1 point. All right, so that was problem number 11, and then there are students that are asking for problem number 12, so let's go through that one as well. The function f is differentiable for all numbers. And okay, so it's going to be really similar, just a new type of problem. Again, this is no calculator, so don't need to pull up anything fancy here. The first thing that I want to find is take the second derivative. It gives us the first derivative, right? So that's the first derivative, and it says take the second derivative. So how do we do that? Let's go ahead and relist the first derivative so we can, well, okay, we're just taking the second. We're taking this derivative again. So do we want to use product rule here, or do we want to distribute this? Either way is fine. I'm going to go ahead and just use product rule, I think. So I'm taking the derivative of that. So this is going to be my 1 and my 2. This is all my 2, right? So product rule is 1 d2 plus 2 d1. All right, 1 is y squared. And by the way, I should write out what I'm doing here. I'm writing down d squared y over dx squared, or more succinctly, I'm just finding y double prime now. So 1, that's y squared, is equal to y squared. The derivative of 2 is going to be negative 2, so times negative 2. Plus, okay, 2 is 6 minus 2x, 6 minus 2x. And d1, the derivative of y squared is 2y, and then don't forget your dinner, times y prime. All right, so we found the second derivative, and then we need to plug in 3 comma 1/4. So I noticed that I can't plug that in unless I have y prime. So let's actually figure out what that is first. So what is, I'll do this in a different color. What is y prime when I'm plugging in 3 comma 1/4? That just means in this equation right here, plug in 3 right here, and plug in 1/4 right there. So what's that going to be? It's going to be 1/4 quantity squared times 6 minus 2 times 3. Okay, let's simplify this a little bit. 1/4 squared is 1/16. This is going to be times 6 minus 6 is, 0. So this is equal to 0. That's kind of nice. So now let's actually, that means this 0 is going to be plugged in right there. That's our y prime. And then I'm just plugging in 1/4 and 3 into the second derivative right here. Let's change colors again. So what I'm doing now is I'm saying, what is, wait, that's not doing the, oh, I see what I did. I should have done that button. Okay, so this is d squared y over dx squared when I'm plugging in the coordinates 3, 1/4. All right, so I'm rewriting the blue essentially, right? So y squared is going to be 1/4 quantity squared now times -2 plus 6 minus 2 times, okay, we're plugging in 3 for x. That's all in parentheses. Times 2y, so 2 times, and then y is 1/4 again, 1/4. And then that's all times y prime, which is 0. And I love when I get to cancel out so much math, because 0 times this times that, that's all 0. So that's all gone. I'm only worrying about this side. And 1/4 squared, as I said before, is 1/16. So I have -2 in the numerator from this -2 right here. And in the denominator, I have 16, and that simplifies to -1/8. Final answer, box it. All right, part B. Find f of x by solving with the initial condition. Okay, so this is your separate, integrate, evaluate, isolate steps. And is it just B? Oh, this is the last problem. Okay, I have tons of room. That's nice. So step number 1, we need to separate. And the reason that this doesn't say the word particular solution is because it's older. This was pulled from probably like early 2000s or maybe the late 1990s. The newer versions usually have the word particular solution in them, but sometimes they do look like this. So I wonder what they're going to have for this upcoming test. Separate. I'm going to have my dy still on the left-hand side. I eventually need my dx on the right-hand side. So I've gotten rid of this one by multiplying both sides by dx. I'll have to divide both sides by y squared. So I'm going to have 1 over y squared on the left over here. 1 over y squared. I'm going to leave this 6 minus 2x on the right-hand side. So 6 minus 2x. Done. Okay, step number 2. I need to integrate. So step number 2 is to integrate. So take the integral. I could write 1 over y squared. I'm just going to write y to the -2 dy is equal to the integral of 6 minus 2x, that quantity dx. All right, let's do some math here. So if I take the integral of y to the -2, it's going to go up a power, right? So y to the -1, then divide down, so it's divide by -1, which is the same thing as just multiplying by -1. So I'm going to say -y to the -1. And that's equal to, okay, antiderivative of 6 is 6x, antiderivative of 2x, or -2x, is -2x squared divided by 2. And we'll add our c there as well. And I can simplify this a little bit because I don't like negative powers when I have to plug things in later. So I'm going to say that this is -1 over y instead of -y to the -1. And I'll just go ahead and simplify this right-hand side just a little bit. So this is 6x minus x squared plus c. So far so good. Let's do step number 3, changing colors yet again. So 3 is to evaluate or plug in. Evaluate. Our x coordinate is 3, our y coordinate is 1/4, just like we were doing in part A. So this is going to be, I'm plugging into this equation right here, right? So I have -1 over, and then y is supposed to be 1/4, and that's going to be equal to 6 times 3 minus the quantity of 3 squared plus c. Okay, I mean, as soon as you do that step, then you get your point on the AP test, but let's go further. So this is kind of the keep it, change it, flip it, and you should know that this is -4. If you don't know how to do that, I'll do it off to the side real quick. So -1, keep it, change it, flip it, 4 over 1, and that is indeed equal to -4. On the right-hand side, 6 times 3 is 18, minus 9 plus c. That boils down really nicely. 18 minus 9 is 9. Subtract the 9 from both sides, I get -13 is equal to c. And cool. That's helpful. So I'm going to go on to the next step. And I realize I should be using all the same color here. So let's go ahead and make all that. Is it possible to make all that black? I haven't learned the command for that yet. Let's just switch back to blue for step number 4 then. Step number 4 is to isolate. So that means that I'm trying to solve for y, essentially. So in this equation right there, let's plug in our c and then solve for y. So I have -1 over y is equal to 6x minus x squared minus 13. Okay, now solve for y. So I can do that all in one step. I think you guys can probably follow that. I'm going to take the reciprocal of each side. So this whole side is technically over 1. Take the reciprocal of both sides. I'm going to flip the left. It's now y over -1, but I'm going to multiply by both sides by -1 as well. So this is going to be equal to -1 instead of 1, because I'm multiplying the right side by -1 as well, over 6x minus x squared minus 13. And I realized that the negative x squared should have maybe gone in front, but whatever. There it is. And there's no tricky things like, do we choose a positive or a negative? No, I think that's it. Done. That was kind of an easier problem. All right, let's move on to multiple choice. So this one is going to be our first problem, number 3. We're going to use Taxman, but before we do that, I don't like fractions. Let's go ahead and change this. So I have the integral from 1 to 3 of x times x squared plus 1, all of this to the power of -1, and that is a plus right there. And then dx to make it formal. You don't need to make it formal since it's multiple choice. And how do we do this? I choose Taxman, or I choose u to be the hardest thing. So with Taxman, you need a u, you need a Taxman, you need a u prime, and u is going to be this x squared plus 1. Taxman is going to be the number out front, this x in this case. And take the derivative of x squared plus 1, you get 2x, so that's u prime. U prime is 2x. And let's go ahead and pay our Taxman. So x over 2x is 1/2. And using all this information, we now can boil this down into the integral from 1 to 3. This x got changed into a 1/2. So let's make that yellow or orange, whatever this color is, 1/2, and then rewrite the rest of this. And this is x squared plus 1 to the -1 dx. All right, so now to take the antiderivative of this, we don't have to worry about dinner anymore because we've done Taxman. Antiderivative, whenever I have a -1 power, it's going to be a natural log, and you could probably guess that looking at the multiple choice answers. So the answer here, I still have that 1/2 that's going to be out front, and this is going to be the natural log now of, I guess this should be absolute value still. Absolute value, x squared plus 1, and absolute value, and then that's evaluation bar between 1 and 3. So let's figure out what that's going to be. When I plug in 3 first, that's going to be equal to, 1/2 is going to be on the outside. I'm not going to worry about that anymore. I'm only going to be worrying about this natural log. So it's going to be natural log of, when I plug in 3, it's 9 plus 1, which is 10. So natural log of 10. I can drop the absolute value because that's a positive. Then I'm going to subtract natural log of whenever I plug in 1. 1 squared plus 1 is 2. Oh, okay. And you're like, hey, that's not an answer. How do you combine natural logs? And the rule that we're invoking this time is whenever I have natural log of A minus natural log of B, this is equal to natural log of A over B. So 10 divided by 2 is 5. So this whole thing is equal to 1/2 natural log of 5. Hopefully that's an answer. 1/2 natural log of 5. Correct answer is D. All right, let me get my phone to find the next problem that we're going over. Looks like number 6. Let's scroll down here. The graph, oh yeah, so which of the following is true, which means the majority of these are false. So the limit as x approaches 3 from both sides, because there's no plus or minus, of f of x. So let's see what's happening at 3. So at 3, when I get closer and closer from the left, closer and closer from the right, I should approach the same height, and I do. That height is 3, and that is not the height that it's asking for. So if this was 3, it would be true, but now it's false. So that's not an answer. We're looking for something that's true. So let's cross off A. The double-sided limit as x approaches 4 from both sides of f of x. Okay, so as I approach from the left and from the right of that point, okay, that doesn't equal anything. So the true answer should be D, N, E, just like the true answer up here should have been 3, but they didn't do that. They said that it's equal to 3, so this is false, and therefore it's not the answer we're looking for. C, f of x is continuous. Okay, what is the definition of continuous? So let me write that up here. To be continuous. To be continuous. It means you have none of the following. None of these four things, right? So you have none of, I was about to write none again, holes, gaps, endpoints, and vertical asymptotes. I guess I should make that capital. Endpoints and vertical asymptotes. And so let's go ahead and look at x is equal to 3 now. So at x is equal to 3, that is, I guess you can call it a hole or a gap, whatever you want to call it. But it's definitely not continuous at 3. So this is saying is continuous, and that's not true. That's false. So that's not the right answer. Okay, what about D? It's continuous at 5. So look at 5. At this point exactly, are there any of these four things? No. So that is actually a true statement. It is continuous at 5, and D is the correct answer. Let's quickly look at why E is false. We know it's false because the answer is D. So saying the limit as the limit of f of x as x approaches 6 from both sides is equal to a certain height. So let's interpret this left-hand side. As I go to x, as I approach 6 from both sides, I get to a height of 4 there, and I get a height of 1 there. So the correct answer for this left-hand side is it does not exist, because it's going to two different points. Saying it's equal to the, this is saying the height at 6. Well, the height at 6 is wherever the point is. If I drew a line at x is equal to 6, where does that line intersect? And that height is right there, which is 1. And D and E is obviously not equal to 1, so that one we can cross off as well. Final answer is C. Next question that was asked was number 14. Let's scroll down here. Number 14. Where are you? Okay. Oh yeah, so this looks like it's an intermediate value theorem problem. So suppose, let me see if I can draw a picture. This might be easier than what I had in the key. Okay, so let's try drawing this. So if I have a graph, f of -5 is equal to 3. So f of, I'll say that this is -5, and then this is going to be -1. So if I go to the height at -5, the height is 3. So I'll say that height is 3. And if I go to the height at -1, the height of -1 is -2. So the height at -1 is, we'll call this down here -2. Obviously not drawn to scale because it's just a sketch. And it's telling us, hey, if f of x, if the height is 0, for one and only one value of x, which of the following could that x be? So intermediate value theorem states, if I choose a height that is in between these two heights, which it is, so we can use it, then the x value has to at least happen once between the x values, between -5 and -1. So which of these numbers are between -5 and -1? That's the answer. So at -7, that's, I'll do this in a different color, -7, that doesn't work. That's not inside this bound. We're essentially looking something inside of, maybe I should change the color to red. Anything inside of this red box is fair game for the intermediate value theorem. So at -7, that's nowhere in that red box. At -2, that happens right there, and that's the answer. That's in the red box. So that's the answer. 0 happens right here, not inside that red box. 1 happens right here, not inside that red box. And 2 happens right there, not inside that red box anywhere. So the correct answer here is B. All right, next multiple choice question. Looks like it's number 30. So scrolling down here to number 30. There we go. Okay, so what is the definition of f increasing? That's the first thing I see, like increasing. So let me draw out the definition. F increasing is where f prime is greater than 0. So first find f prime, and then make sure that's greater than 0 by setting it equal to 0, and then looking for their intervals. So if this is f of x, f prime of x, taking the derivative here is 3x squared plus 6x minus 9, and the derivative of a constant 7 is 0. So there it is. I'm going to go ahead and set this equal to 0. So this, and I'm going to factor it as well. What is the greatest common factor? 3. So I was going to say 3 times what's left over, x squared plus 2x minus 3 is equal to 0. A lot of the tricks that the AP test will try to do is they'll make you factor out a negative because you'll have a negative coefficient in front of your x squared, and that will mess you up. Luckily, we don't have that, so it's not that tricky, I suppose, compared to another type of problem. This is going to be a ninja star that I can use to factor. So ninja star, chunk, chunk, 2 and negative 3. That's 1 and 3, or this one is the negative. So this is now going to factor as 3 times x minus 1 times x plus 3 is equal to 0. And then from here, I'm just going to solve, and I say x is equal to 1 and x is equal to negative 3. What do I do with that? Well, I plot it on a number line. So there's negative 3, there's 1. I just have to check which of these intervals are positive and negative. And as a note, look at this. This is to the power of 1. This is to the power of 1, which means it's going to switch signs since this is an odd power. So if I just need to find one of these, and then it's going to switch over each of these critical values. What's the easiest one? Probably here at 0. So if I plug in 0 into this guy right here, always plug into like the most original possible thing. I could plug it in here, but it's a little bit harder. 0 minus 1 is negative. This is a positive, so it's a positive times a negative times 0 plus 3 is a positive. Positive times a positive is a negative. Let's undo those. So I have a negative on that interval, which means I have a positive and a positive. It'll flip over those critical values. And I'm looking for where it's increasing, which means I'm looking for where it's positive. So whenever it's less than negative 3, this is saying less than negative 3, or it's greater than 1. Greater than 1. Correct answer, C. Next question I should be going over, looks like it's number 40. Let's skip down to number 40. Oh, yeah, the tables and finding first and second derivatives. Yeah, so this one, I think maybe talked about maybe twice. Can't remember which unit. But you're looking for first and second differences. So first derivative is, another way of thinking of that is your first differences. And I'm just going to abbreviate that by saying first difference. And second derivative is the same thing as second difference. It's a tool that we use nowadays in Algebra 2 to analyze functions for their first and second derivatives without doing any calculus. What that means is that all the first differences have to be positive and all the second differences have to be negative. So what does that mean? It needs to be increasing, first of all. So anything that's decreasing, like C or D or E, has a positive first derivative. Yeah, so those are immediately eliminated, right? Because those are going down. For example, if I look at their first difference, to get from 16 to 12, I have to go minus 4. That's the first difference. Well, that first difference is negative, and I'm looking for a first difference that's positive. Same thing over here. That's minus 2. Oh, what happened there? Minus 2, and this is minus 3. So all of those first differences are negative. It's between A and B now. Okay, let's go ahead and find their first differences. So this one I did plus 2. Man, I still need to get the hang of how to use this. So I'm just going to say plus 2, then plus 3, then plus 4 to get from 7 to 9, 9 to 12, and 12 to 16. Okay, from 7 to 11, I went plus 4, 11 to 14 did plus 3, and then from 14 to 16, I went plus 2. Those are all the first differences. Notice that A and B have positives. Let's just find their second differences. So I'll do that in a different color like yellow. To get from 2 to 3, I added 1. To get from 3 to 4, I added 1. Those are positive second differences, and we're looking for negative second differences. So the answer is B. Let's check it. To get from 4 to 3, yep, minus 1. To get from 3 to 2, minus 1. So positive first differences, negative second differences, that is the answer. Next question is 45. Number 45. Ooh, yeah, approximation using the line tangent to the graph. Okay, so every single time that I see the words approximation or line tangent to the graph, mainly the line tangent to the graph, that happens more often than other things, that means I'm doing y minus box is equal to box times x minus box. And it gave us all those values essentially. So it told us, hey, x is 1, y is 4, x is 1, y is 4, and then it tells us the second derivative and says, hey, just plug in this 1 into this second derivative and you'll get the number that goes in this box right here. So plugging in 1, 2 times 1 is 2, plus 1 is 3. I now have a line that can approximate this 1.2. So plug in that 1.2. Let's do a new color here. So I now have y minus 4 is equal to 3 times, okay, I'm plugging in 1.2 for x minus 1. That's going to be y is equal to, I'm going to add 4 to both sides in a sec, but first 1.2 minus 1 is 0.2. 0.2 times 3 is 0.6. Then I have to add 4 to that. I should be looking for 4.6. Correct answer is D. Next question that was being asked was number 48. So number 48, horizontal tangent line. Okay, so whenever I see the word horizontal tangent, that means that the y prime is equal to 0. Tangent means y prime. Horizontal means that the tangent looks like horizontal, not vertical, but horizontal, right? So essentially it's asking us set y prime equal to 0 and solve. We don't have any y prime, so let's go ahead and take the derivative. Yeah, so it's a little bit hard to do in this case, but we can do it. So it's going to be 2y y prime, that's the derivative of that y squared. Remember, it's always with respect to x, which is a y. We have a y prime here, minus 3x squared minus 30x, and that's still equal to 0. And it's saying, hey, y prime is 0. So if y prime is 0, that means that this y prime right here, you're 0, and that whole term is gone. It's non-existent. And I'm basically solving negative 30x squared minus 30x is equal to 0 and solve. So first thing I'm going to do is I'm going to multiply both sides by negative 1, and I get this new equation that says 3x squared plus 30x is equal to 0. Let's divide both sides by 3 while we're at it. So x squared plus 10x is equal to 0. You can't divide both sides by x because what if x is 0? And it clearly could be. So if I divide by 0, that's committing a mathematical sin. But what I can do is I can factor out an x. So if I factor out an x, it'll look like this. I'll have x times the quantity of x plus 10 is equal to 0. And using the zero product property, I can say that this x is equal to 10, or x is equal to, sorry, what did I say? X is equal to 0, or x plus 10 is equal to 0, or x equals negative 10. So there are two values that make this have a horizontal tangent. And we don't have to worry about any weird thing happening in a denominator because we don't have a denominator. Sometimes you might have to eliminate one of these if it's not on that line. It's not a possible point, but no such cases. So 0 and negative 10, our correct answer is D. Next question that was being asked is number 49, then 60, then 64, and I think that'll be it for us. So 49. Yes, so related rate problem. So area is increasing. So that's A prime that's talking about. This area increasing is A prime. And that A prime is equal to 96 pi. So over here I'm going to say A prime is equal to 96 pi. Those are my notes from my problem. When the area is, so this is not an A prime, this is just area is 64 pi, how fast, so this is the question, is the radius increasing? So what is R prime? That's the question. All right, so we need two different formulas. I need a formula for A and a formula for A prime. So first, A, the area of a circle is pi r squared. And if I plug in some things, that'll probably be helpful. I don't have very much room here, do I? Let's go ahead and plug in our A. So this is going to say 64 pi is equal to pi r squared. Well, we can solve and get an r, right? Divide both sides by pi. That will cancel out the pi's. And r squared is now equal to 64. Let's take the square root, and r, therefore, is equal to plus or minus 8. And it doesn't make sense to have a negative radius since we're in the physical world. I don't know what a negative radius looks like. So it's just 8. Okay, so we have r is equal to 8. I guess I shouldn't box that. It's not like a final answer or anything. We also need a formula for A prime. So let's come over here. If I take the derivative of area with respect to time, so that means I'm going to have an R prime in this. So A prime is equal to, well, the 2 is going to come in front, right? So it's going to be 2 pi R prime. And then plug in what we've got. We've got an A prime, that's a 96 pi. We've got a 96 pi. We have a 2 pi. We know the radius. We actually solved that without even knowing that we needed it, and that was 8. I'll change to black so we can follow that work. That's times 8 right here. And then finally times this r prime that we still don't know, and that's what we're trying to solve. So literally just divide everything to find the answer. Okay, so what am I going to do here? Let's go ahead and divide everything by pi. Those pi's are gone. Divide both sides by 16, I guess. What is 96 divided by 16? I can't do that in my head. I'm going to guess it's like 6 or something. Is 90, well, let's do 96 divided by 8. That's 12, right? 12. And then divide by 2 again, because I haven't divided by this 2, I only divided by that 8. And 12 divided by 2 is indeed 6. So the answer here is A, 6. That was 49. I said the next one I'm doing is 60, and then 64. Scroll down here. 60. Ooh, yeah, definite integral. And I have a radical and I have a fraction. So let's get rid of both the radical and the fraction from the get-go. So this is now going to be the integral from 0 to 8 of 1 plus x, and this is all to the power of negative 1/2 dx. Negative because it was in the denominator, and 1/2 because it was a square root. When I take the antiderivative of this, it's going to go up a power. So it's now going to be, I'm taking the antiderivative, I'm not going to write the integral now, so it's going to go be 1 plus x. All of this to the power of positive 1/2, and then divide down. So dividing by a half is the same thing as multiplying by 2, so there it is, divided down. Now that's evaluation bar from 0 to 8. One thing I'll note is I didn't do taxman. I should have, but I knew that taxman was 1. So the derivative of 1 plus x is 1. So whenever taxman is 1, you don't have to do it. I guess I should be more consistent in trying to do taxman so that you can get in the habit of always doing taxman every single time you have an integral as well. But here we go. Let's continue. So when I plug in, I guess I can look ahead of time. When I plug in 0 for my second step, I'm going to actually have something. So be warned of that. I'm going to have 2 parts. So let's plug in 8. 8 plus 1 right here is 9. 9 to the power of 1/2 is really the square root of 9, and the square root of 9 is 3. And let's go ahead and leave that 2 factored out. I don't want to worry about the 2. So it's 3 minus, and then when I plug in 0, 0 plus 1 is 1. 1 to the 1/2 power, the square root of 1 is 1. Okay, 3 minus 1 is 2. 2 times 2 is 4. Correct answer is D. And I guess I should be looking at my answer key. I haven't been looking at it this entire time. Do we get number 60 correct? Let me scroll down and say, yes, I got D as well. And then number 64, and then we're done. Although I will note, I haven't heard from Geo or Arrow, so there might be more problems I'll do in the future. That will just be another video. Number 64. This thing has a horizontal asymptote and a vertical asymptote. I have to find the values of A and C. Okay, so what does it mean to have a horizontal asymptote? The definition is where I take the limit as x approaches infinity, and I will get the vertical asymptote, which is 2. So let's take the limit as this thing goes to infinity. So whenever I have the limit to infinity, that's always the top-bottom rules. So top-bottom, this is the power of 1, power of 1. So essentially I'm canceling out or I'm ignoring the B and the C, and then I'm simplifying this fraction. We're taking the coefficients, really, right? You're looking at their coefficients, A and 1, and that's A over 1, which is just A. So I'm now saying that A is equal to 2, because the limit as x approaches infinity of this thing is A. So this limit is A and is still equal to 2. That's why I got A is equal to 2. I feel like I'm not explaining that as clear as I could be, but now we have A. To find C, I'm going to guess we're going to have to use the vertical asymptote, because those are the 2 pieces that we haven't used yet. Vertical asymptote is whenever the denominator is equal to 0. So I'm going to set this x plus c is equal to 0. So x plus c is equal to 0. And that happens at x is equal to negative c. Oh, and then what is that x coordinate? The x coordinate is negative 3. So I'm going to come back here and say negative 3 is equal to negative c, and therefore c is equal to positive 3. It's asking us, hey, add this a and c together. 2 plus 3 is 5. Correct answer is E. And I guess I can check my answer key really quickly off the side, and I did get E as well. Cool. Well, that concludes the video on going over all the problems that students had questions on from all of the final exam prep from units 1 through 5 and 6 through 11. If you guys have more questions, just send it to that group text and I will make a video on it. I'll see you guys later.